Okay, so what we're going to do here is look at different equations and how to use them with word problems for this first unit. So we've already done a little bit of this where we've talked about speed is equal to distance over time, and we've also figured out that velocity is equal to displacement over time. All right, so these are the two main equations that we're going to look at. We've had a few other in there that I'll reference later. The first thing I want to do is I want to rearrange each one of these algebraically so that you can see the different forms of these equations. You're not going to be expected to do that on your own. You'll be able to get your list of all these different versions of the equations so that you can just figure out which one to use, not how to rearrange them. So if I want to rearrange both of these to solve for the like the distance or the displacement, well, I could move that time over to the other side for both of them, and it's speed times time. All right, or you could have displacement equals velocity times time. So you can see how they're similar. Again, the velocity stuff, these are vector quantities, and the speeds are not. They are scalar. And we could then rearrange that, say, for the time variable. All right, so time in each of these is distance over the speed, or over here, time is equal to displacement over velocity. All right. Now, I do want to do one more thing here. I could break this guy down right here a little bit more. Now, you know from before that we've already solved for displacement. Displacement is really the difference between the final and the initial. Okay, well, if I take this and plug it into here, all right, well, that works out to be this equation up top here. All right, and we actually have already solved this before when we used y equals mx plus b. All right, that on the slope is describing the velocity, the initial velocity, or excuse me, initial position is the y-intercept. That time is measured on the x-axis, and your position, where you end up, is this. This is just the equation that we've derived from the very first lab, but in mathematical form now. You can kind of see how that works. All right, so we're going to use these guys to solve several different examples here, and I'm going to walk you through. But first, there are certain steps that I always want students to show. All right, step one. All right, list what you know. Two. All right, pick an equation that solves for what you need to find. Okay, if it's a single step formula, all right, you just need one equation. Sometimes you might need two, so it's a little variation here, but you're going to find an equation and obviously write it down. So I want to see that equation. 3, plug numbers in. Okay, so you're going to take that equation, plug in everything that you know, all right, and then 4, circle your answer, because you're going to plug that in to your calculator. All right, and that is always with units. So very important that you learn this problem-solving method here, because when you are stuck on something that's very abstract later on, I'm going to ask these 4 questions. Okay, what do you know? All right, what equation solves for what you need? All right, did you put those numbers in, and then where your answer in units? All right, it's really that straightforward. So let's go on into this first one. All right, it's got two parts here actually. Frankie football runs from the 50-yard line to the 20-yard line in a matter of 7 seconds. Calculate Frankie's speed and velocity. So on this side, let's go with speed. This side, velocity. All right, first off, if I'm going to go to the speed, what do I know? Well, he goes from the 50-yard line to the 20-yard line. Well, that's actually a distance, something I can get, right? So let's use that. 30 meters, or excuse me, yards in this case. So I know he travels 30 yards. And I know he does it in 7 seconds. So that's what I know. Step one. Step two, I'm solving for speed. Well, I know that speed equals distance over time. Those are the only two, or the only equation that allows me to solve for speed. So if I'm asked to solve for speed, I need to know those two things. And sometimes that's the case. There's only one equation that lets you solve for what you want. Okay, let's plug it in. Step three. Speed is equal to 30 yards over 7 seconds. And so that means, let's see here, 30 divided by 7, we'll call that 4.3 yards per second, because I'm just keeping those. They don't cancel each other out. And then circle. Okay, I'm not going to be really picky on how far out you go with your decimals. It would be really nice if we could cover those significant figures, but I'm more interested now in the process, not necessarily those fine details. So let's just move over here. Okay, I'm going to do the same thing, calculate velocity. Again, I still know the time is 7 seconds, but with velocity, all right, if I'm asked to find velocity, I need displacement, not distance. So I'm going to break this up just a little bit differently. I know that this is my initial. This is my final. Okay. Scooch that down a bit. Well, remember that displacement is final minus the initial, which means my displacement in this case is not the same thing as my distance over here. It's actually a negative 30 yards. Okay, because it's moving in the opposite direction. So my velocity, that's step one. All right, step two is write out equation. All right, the only one that can solve for velocity is this one here. Plug in my numbers because I have all that. So the velocity is negative 30 yards over, that's 7 seconds. So again, I'm getting basically the same stuff, but since velocity is a vector quantity, it gives me a direction that's in the negative. So 4.3 negative yards per second. Circle answer. There's my 4 steps. Let's try another one. Has maximum velocity. Frankie can run at 3.5 yards per second. So I'm going to go ahead and stop right there for a second. I know that his velocity, 3.5 yards per second. How far can he travel in 4 seconds? T, 4 seconds. Okay, so how far? All right, what is that asking? All right, it could be asking a distance, all right, or a displacement. Both of those, as long as they're moving in a straight line, could work. All right. So what we want to do then, all right, is solve for a displacement. Well, there's only one. Displacement is velocity times time. I have both of those. So let's plug them in. displacement is equal to 3.5 yards per second times 4 seconds. Now, this is not something you need to do, but it's nice to see units canceling out. Since the seconds on this is at the bottom of the fraction, this is just a whole number, which basically acts as s over 1. Okay? You can cancel out those seconds, leaving only the units that we want, which are yards. All right, and then let's see here. .5 times 4 seconds is 14. So I have a displacement 14 yards. We're going to do one more. Frankie Football's max speed drops to 3.7 yards per second. Okay, so it's giving me speed. 3.7 yards per second due to a pulled hamstring. How much time will it take for him to run the football 15 yards? Well, we're talking speed, so this here has to be a distance. Right? It's asking for how much time. So that means the equation I'm going to need is t equals, well, I've got 2 times, but the only one that deals with speed and distance is distance, or excuse me, yeah, speed and distance is time equals distance over speed. All right, plug them in. 3.7 yards per second over 15 yards. Oops. Try that again. So plug it in. So we have 15 yards over 3.7 yards per second. All right, and the yards will go away, leaving me with just the seconds. So the time is equal to, all right, 15 divided by 3.7. We'll call that 4.1 seconds. Okay, now we didn't do all of these different equations examples, but the process is the same. All right, you identify what you have, figure out what it's asking to solve for, and pick an equation that will allow you to solve for that. Write it down, plug in the numbers, circle your answer. Those are the 4 steps that are critical. If you have nothing written down, then you don't get any points. All right. The very minimum to receive points in my class for trying is at least writing down what is known. And then you should at least try to pick the equation out. If you can, if you have enough information, then at least try to plug in those numbers and come up with an answer. If there's something wrong with it, we'll cover any questions that you have in class.